Okay, so today we are starting resolving of vectors. Or else it is also known as resolution of vectors. Okay. So write down the topic, resolving of vectors. Now, for example, let's say I have a vector. I write in this direction. So okay, so here's a vector. Let's say this vector is P. Can you hear me clearly?
Yes, sir.
Okay. So this vector is P vector. Hold on. So this vector is P. Now this vector I want to resolve into two perpendicular components. So if I say this angle is theta, this angle is theta, then I can resolve this vector into two perpendicular components. As towards the angle, it will be P cos theta. So this one is P cos theta, and then the other component I can as P sin theta. P sin theta. And they are perpendicular. So now let's say, for example, you have vector P. If you want resolving means you divide into two components so that their resultant will be equal to the original vector. Do you understand? Okay. So here this vector P, I resolve into two components. Okay. Then the resultant of these two components must be equal to the vector P. Is that clear?
Yes, sir.
Okay. So write down the note. Generally, a vector is resolved into. Okay, so first we write what is the meaning of resolving means. Okay, right. So resolving of a vector means dividing a vector into small vectors. Dividing a vector into small vectors so that their resultant will be equal to the original vector. Okay. And then next line you can write. Generally, a vector is resolved into two small perpendicular vectors. Within brackets, you can write components. First up. So normally we take a vector and resolve into two perpendicular vectors. Okay. So now here this example you can find. Yeah, sure. Generally, a vector is divided into two small perpendicular components, perpendicular vectors within brackets component. These small components, these small vectors are known as components. So these are the perpendicular components of this vector. Okay, it is known as perpendicular components or rectangular component. Okay, okay, and then you can put as an example, and then you can write this down. Okay. So now I'll give you, okay, first we'll find whether what we have done is true or not, right? Now here this vector P I have resolved into two components. One is P sine theta and P cos theta. So if if we calculate the resultant of these two, then it should be equals to P, no? Do you understand?
Yes, sir.
So here, now let's try to find the resultant of these two components. So resultant, let's say it will be R. Is R acting in this situation. Okay. So then we can find R squared is equals to, we know, is equals to, for example, if we have two perpendicular vectors x and y, and their resultant R, we know how to calculate, no? So R is equals to x squared plus y squared square root, right? This is how we calculate the resultant, right? We did this in our previous class. All right, so similarly, here the resultant of this, we get P sine theta squared P sine theta square plus P cos theta square. Okay, so therefore R squared is equals to P squared sine squared theta plus P squared cos squared theta. Therefore R squared is equals to P squared is common, we can take out. So we get sine squared theta plus cos squared theta. What is sine squared theta plus cos squared theta? What is this equals to?
1.
1. Yes, this is equals to 1. So therefore, R squared is equals to P squared. So here R is actually, I'm taking the magnitude. Let's say we are talking with this, let's put the vector notation, this P vector. Therefore, P sine theta, this is P cos theta, and this is R vector. Okay. So here I consider the vector notations. Okay, so here I take the vector R, R vector magnitude is R, and P vector magnitude is P. So I'm writing in terms of magnitude. So magnitude is always greater than 0, therefore R is equals to P. So then therefore the magnitude of the resultant of these two is equals to P, and then now I'm going to find the angle. To find the angle, I can take this as alpha. So I can write tan alpha equals to opposite over adjacent. So opposite is P sine theta over P cos theta. So P and P cancel. So therefore tan alpha equals to sine theta over cos theta is tan theta. So now tan of an angle is equals to tan of an angle. Therefore alpha must be equal to theta. So you can see that this angle is, so when we calculate the resultant of these two components, P cos theta and P sin theta, their resultant, the magnitude of the resultant is equals to uh, the original vector. So you can see the resultant is equals to the magnitude of the resultant is equals to the magnitude of the original vector, and also angle also the same. So same magnitude, same angle, therefore R vector is equals to vector P. Is that clear?
Yes, sir.
Okay. So therefore the summary is, now if we have a vector P making an angle theta, we can resolve that into two components. So towards the angle it will be P cos theta, and the other side it will be P sin theta. Okay. So I'll do an example. Yeah. Okay. So let's do an example. Okay. Example. So I have two vectors. Sorry, I have a vector. For example, a force 20 Newton. It would making an angle with the horizontal something like 30 degrees. Okay, now if I want to resolve this means, how can I resolve this? I can resolve this into two perpendicular components. So one is in this direction, the other one is this direction. Okay, so this towards the angle, it will be P cos theta. So therefore here 20 cos 30. So 20 cos 30, and this one will be 20 sin 30. Is that clear? So here the unit is Newton, so in the unit of Newton. Is it clear?
Yes, sir.
Okay. So you can write this example.
Sir, done.
Okay. So I'll do another example. Let's say I have a vector. For example, 10 meters per second can be a velocity. Making an angle, say 45 degrees with the horizontal. I want to resolve this. So resolving this vector means I want to divide into two components. so that their magnitude is equals to so that their resultant is equals to the original vector. Okay, so now I take this into two components. Yeah. So one is like this, and the other component will be okay. So the other component should be from here vertically upward. So this actually comes like this according to triangle of vector addition. Do you understand? We didn't do the triangle law of vector additions yet, did we? We did, right?
Yes, sir, we did.
We did. Okay. So you can see then this component are actually according to the triangle of vector addition. So then this is the vertical component. It's actually like this. When you are drawing graphically, it has to be form a triangle like this, perpendicular triangle, because we are dividing into two perpendicular components. So you will make a perpendicular triangle. Okay, so therefore the components I can write. This will be something when shown 10 cos 45 towards the angle cos. The units meters per second, and here 10 sine 45 in the units of meters per second. Okay, so you can write this as a second example, and then I'll give you some questions you have to do. You have to resolve it. The resolving of vectors, also known as resolution of vectors.
Sir, done.
Okay, so I give you some questions. You have to do it. So, okay, so the question is resolve the following solve solve the each of the following vectors into two perpendicular components. We solve each of the following vectors into two perpendicular components. So here the first one, say 20 Newton, angle is 60 degrees. This one. Second one, You can start doing the question. Thirty degrees, 12 meters per second square. Third one, okay, so here 10 questions, 6 questions are there. I had to do these questions. Already, how many questions you have done?
4 questions, sir.
Sorry,
4 questions.
4 questions. Okay, good. Can you send me your workings up to question number 4?
Sure, sir.
Okay. You can share it through Zoom chat to TKI. Okay, so here 20 cos 60, 20 sin 60. 12 sin 30, and here 12 cos 30. Units correct. 8 cos 45, 5 sin 45. Okay. So you can complete the other questions also. So today I will be only covering resolving of vectors, but in our next week class we will be doing more like finding the resultant, the magnitude and the direction of the resultant of two vectors which are making an angle between them. So that part we will be doing in our next class. So within another two class we can finish the vectors theory completely. Okay. All right. So do you have any questions?
Sir, can you explain the center of mass and center of gravity?
Center of mass and center of gravity. Okay, yeah, sure.
Sir,